Hello, my name is Sebastian Gutierrez-Olvera, and I want to talk to you about tularemia. So, tularemia, otherwise known as rabbit fever, deerfly fever, or Francis's disease, is a disease that occurs mainly in animals, but we saw the jump later to humans, so we can note it as zoonotic. It's also interesting, it might have been the biblical Philistine plague. There are some papers that talk about that. But let's talk about the infectious agent, because tularemia was first formally described in 1911 by Edward Francis, the same biologist that would later go on to attribute tularemia to the causative agent Francisella tularensis. But originally, in all of his works, he referred to it as Bacterium tularensis. The genus would later go on to get renamed in honor of all of his work. Now, modern day, we've done some further work. We have adjacent species and some of the subspecies. But let's talk about the basics. So it's a gram-negative coccobacillus. It's highly, highly, highly infectious. It takes only about 10 to 20 individual organisms before you actually get an infection. It's non-modal. It's an aerobe. It exists very well intracellularly, which is interesting because it is a bacteria. It's a slow grower, so infections kind of are spread out. And like I said earlier, it is zoonotic. And that moves us to the transmissions. So there are a bunch of different ways to actually get tularemia infection, or F. tularensis infections that later result in tularemia. So there are insect bites, like deer fly, ticks, mosquitoes. This is where it gets the name rabbit fever, because people would be raising rabbits or hunting rabbits for meat, and because they were around the wild game so much, some of the ticks would go off and bite them and then transmit the disease to them. There are other ways, such as like animal bites, handling infected tissues or fluids. Like if you're skinning a rabbit, if you have any cuts on your hands, some of that blood could get into you, and that could have F. tularensis in it. Tainted meat could also do that. Tainted water. But notably, it's not transmissible between human to human contacts. Those transmission methods are kind of standard for type A and type B. So type A is our highly virulent strain. That's the one that we care about mainly in the US because it's prevalent throughout all 49 states. I'm excluding Hawaii because that's very far away. It's the main one that we like to think about, and it's the big one for something that I want to talk about later. So type B would be Holarctica, which is found throughout the northern hemisphere. Here in this map, you'll see that the highlighted regions are parts of Canada, parts of Alaska, the US, parts of Mexico, and then a whole strip across Europe and Asia. That's Holarctica at that point. It's one of the more common forms just because it's spread out throughout that area. We have two other forms which aren't referred to as type A or type B. It's Mediasciatica, which is in Turkmenistan and Kazakhstan. Those are moderate virulence levels, but not super important for the purposes of what we're talking about. And then Novacita. Again, these are mainly smaller strains that we don't see as too important to talk about for today. So let's talk about the pathogenesis. The most important thing about how this F. tularensis actually causes disease is that it is able to evade the innate immune system. It will sit inside. It will use those type 4 pili to attach onto cells, especially macrophages. They're in the hopes that they'll be phagocytized, because as soon as they are phagocytized, they're able to escape the phagosome before the granulosome actually merges together and starts going through the whole process of phagocytosis. And once it escapes that phagosome, it's able to replicate freely throughout the interior of that macrophage until it actually gets so populous that it bursts the cell. Very similar to viruses, actually. And this leads into some of the symptoms. It also affects neutrophils as well, but its main target is those macrophages, but it can affect other cells as well, not just immune cells. But because of all of that, it has different effects based off of the routes of transmission. So we see a lot of different signs and symptoms. So in the ulceroglandular and glandular form, we'll see those skin lesions, which are those are one of the first signs that you'll end up seeing, and it's very difficult to diagnose at first based off of these because you might have a bunch of different mosquito bites and you don't know which one will be infected with F. tularensis. Eventually, though, that will get a lot worse and then end up scarring, like that image that I have right there. Along the same time that you start to see that's the worsening of that skin lesion, you'll start to develop a fever. And then a couple days further down the line, you'll see these enormous, very large and swollen lymph nodes. And this is kind of the most common form. This is the one that's vector-borne. These are the ticks. This is direct contact with an infected animal, like whenever you're skinning or dressing an animal that you've hunted, or touching tools that were used to do that can also pass that along. And along those lines, if you are working with them, you're still susceptible to the oculoglandular form. This commonly occurs by touching your eyes after touching an infected surface or just some source of infection. So we'll see fever, the swelling of the lymph nodes, kind of the similar symptoms that we see, but now you just have the main infection occurring in your eye. So you'll see swollen lymph nodes, especially under the eye. You don't really see it too much in this photo, but you do see the swelling of the eye. You'll see conjunctivitis, which is those crusts that you'll see. You'll start crying a lot. You'll develop photophobia, so you'll be very sensitive to light. And in some cases, you'll see corneal ulceration, which is just brutal. But this is one of the more uncommon ones. I believe from some of the facts that I saw from the WHO, it was less than 1% of cases. And that takes me to the next, which is oropharyngeal, which you get this form from drinking infected water or contaminated water. So you'll see stomatitis, pharyngitis, redness. In this, I believe this is a CT scan. You can see those swollen lymph nodes, just as it's constantly attacking those macrophages and just kind of stockpiling and growing. You'll see the pustular, I believe, I put changes because that's what was in the original source document, but I thought it was charges, just different not droplets, but like little pustules throughout your mouth and throat. In some cases, there's vomiting, bloody diarrhea, or normal diarrhea, and then abdominal pain. It depends on how far the infection is spread through your digestive tract. And unfortunately, with this form, it's often confused for strep in the early stages, and penicillin is given initially. Now, penicillin doesn't actually affect F. tularensis, which becomes an issue at certain points, because you kill some of that competing microbiota throughout your system while leaving the F. tularensis just there to proliferate. The next form is the pneumonic form, which this is from inhaling aerosols. Now, I have this photo of Martha's Vineyard because there was a very notable occurrence there. Essentially, it boiled down to two guys were mowing their lawn over here, and they came down with the pneumonic form of tularemia. This is because it's hypothesized that while they were mowing the lawn, they ran over an animal carcass, which aerosolized after shredding the carcass to pieces. It aerosolized the F. tularensis, and they breathed it in. So we'll see pneumonia in some cases, fever, again, those normal symptoms of fever and the swollen lymph nodes are prevalent here. Coughing, bloody coughing in some cases, shortness of breath with his dyspnea, chest pain, muscle aches, red bumps, or rash. And then our final form is kind of our catch-all. It's typhoidal. Now, typhoidal form, I couldn't really find any good photos specifically of this because, again, it's just the catch-all at this point, according to the World Health Organization. They recommend really only using this term when route of infection isn't able to be clearly established. So that's why we see a ton of these symptoms of high fever, chills, headaches, loss of appetite, muscle aches, sore throat, abdominal, and so on. This is, again, just the catch-all. So enjoy the little bunny, I guess, because I couldn't find anything for it. And now the bunny's gone. So let's talk about treatment and prevention. And the reason that I want to talk about that is that untreated tularemia has a 30% to, in extreme cases, 60% fatality rate. That's very high, and it's very unfortunate in areas that don't have good medical capabilities, because that will just ravage through that population, especially because treatment is kind of easy. It's just antibiotics in injection or pill form, depending upon how far along you are in the actual infection. So I have my list of antibiotics there. Again, notably penicillin's not on there. Neither is amoxicillin. And the key thing here is just it's pretty easy to prevent because of the fact that humans can't transmit it to another human. So we just need to take care of the zoonotic process, which would be just bug repellent with DEET to prevent mosquitoes and ticks from deciding to bite you. Wearing long sleeves can also help with this, and then avoiding dusk and dawn when those mosquitoes are most active. Obviously, like I mentioned earlier with that Martha's Vineyards case, let's try and avoid mowing over animal corpses, and at the same time, avoiding drinking water from contaminated sources or unknown sources is also a very good course of action. Unfortunately, on the topic of prevention, there aren't any approved vaccinations right now. There are 2 different vaccinations, including a live attenuated one, but it's very risky because of the fact that tularemia can supersede the innate immune system, and there were a lot of issues with maintaining that in its weakened state, because it would revert a lot of the time back to its active state. And that leads into the history that tularemia had as a potential bioweapon. So during World War II, there was a lot of research done, notably by Japan and some of the Western countries as well, to use tularemia in a biological warfare capability. There was no notable release. It was never documented, but Ken Alibek, a Soviet biologist that actually worked with tularemia here and there, did note that the outbreaks that the Soviets and the Germans were experiencing were probably the result of an intentional release. Now, if that was an Axis or an Allied release is still unknown from what I was able to find. And this development continued into the Cold War in the 1950s through the 1990s. The Soviet Union and the US were both conducting concurrent research on weaponizing tularensis, F. tularensis. So the US actually ended up developing their bioweapon and stockpiled it, as did the Soviet Union. Some other research occurred at the same time, trying to produce vaccines, but none of them were fully approved for use in humans. And the crazy thing about all of this is that there were volunteers that decided that they were going to be aerosolized with F. tularensis. And they knew that they could be cured through the antibiotics, but that's still some incredible dedication. And that takes us to today, where tularemia bioweapons have been destroyed. But there's still research to be done on the vaccine and prevention. Thank you.